Good evening, my viewer. We shall be continuing with our series of videos in trigonometry. This evening we are going to be looking at some more examples of the topics we have covered. And in our first example, we are saying solve the following equations. And our first equation is cos 3 theta is equals to root 3 over 2 in the range 0 and 360 inclusive for theta. In our solution, we are saying cos 3 theta is equals to root 3 over 2, and once we make 3 theta the subject, we get the arc cos of root 3 over 2, which gives us the angle 30 degrees, and therefore 30 degrees is our principal value, like I explained in our first videos. So we shall use our general formula for cos theta, which is 360n plus or minus theta, considering 30 as our principal value. If we want to get the other values for 3 theta, we shall have 360n plus or minus 30 degrees, which is our principal value. And because we are dealing with 3 theta now instead of theta, we shall get our new range. How do we get it? We multiply our first range by 3 all throughout, giving us 0 times 3, which gives us a 0, theta times 3, which gives us 3 theta, which we are actually looking for, and 360 times 3. Our range now is 0 to 1080 degrees inclusive for 3 theta. Now when n is equal to 0, 3 theta is going to be equal to negative 30. That is if we use the negative, and then if we use the positive, we get 30, because 360 times 0 is 0. And for n is equal to 1, we shall have 330 degrees for the negative and 390 degrees for the positive. And we also get the subsequent angles, like you can see 690, 750. And then when now n is equals to 4, we get values that are outside our range. That's why we do not include them. And therefore for 3 theta, our angles are going to be 30, 330, 390, 690, 750, 1050 degrees. All those angles are in degrees. Now if you want to find theta, we divide all those angles by 3, giving us 10, 110, 130, 230, 250, and 350. And so most people make a mistake from somewhere here. After they get 3 theta is equals to 30 degrees, they now divide at that particular moment, saying theta is now equals to 10 degrees. And from there they will use our formula like we have used also, saying theta is equals to 360n plus or minus 10 degrees. And of course they will get their angles when n is equal to 0, that is 10, and when n is equal to 1, 350 degrees and 370 degrees. When n is equal to 2, they get theta out of range, so they will only have 2 angles. Yet for us we have gotten about 6 angles. Now if you divide at this moment, you're going to get wrong values. That's why I cancel out that method. Take care about that. So alternatively, instead of using the general angle formula, we can use our triangle. Of course we still get the range because we want to avoid dividing at this step. So we get our new range, which was 0 to 1080 degrees inclusive for 3 theta. Then we draw our diagram aside, and of course if it goes up to 1080, then we are going to rotate 3 times. Are we okay? We're going to rotate 3 times. So we begin with 0. The first rotation takes us up to 360, and then from 360 up to 720, that is the second, and from 720 to 1080, that is our third. So we look for regions in which cos is positive, and those regions from acts we shall have all are positive, and then in cos, so we shall create those angles. Now as we move, starting measuring from, of course, the x-axis, the positive x-axis, we move, and where we find our first arc, we get 30 degrees. Once we continue, we get 330 degrees, and as we make the second rotation, we get 390 degrees and 690 degrees. As we make the final one, which is the third in red now, we get 760 degrees, and then finally 1050 degrees, and that is with a triangle. But those angles are for 3 theta. We now get for theta by dividing those angles by 3, and we shall have 10 degrees, 110 degrees, 130 degrees, 230 degrees, 250 degrees, and 350 degrees. Once you compare those two answers, they are similar. So take care. Thank you for watching the videos.